And then this is our isolated high voltage testing. We can go up to 3,000 volts with a programmable power supply. A lot of failure analysis as well as dielectric or high pot testing.
So what type of components would you use to push these? So capacitance, capacitors?
Capacitors, but not for capacitors.
Okay.
Capacitors have a resistance to voltage test. They're supposed to break down, or they're supposed to withstand a certain amount of voltage. Mm-hmm. So if you have a weak device that's being sold as a strong device, when we push the voltage through it, it will crack.
Huh.
Actually, they tend to pop or smoke. But also high-power devices and curve trace. Curve trace is really a failure analysis tool.
Okay.
It's for measuring 2 points and looking for the connectivity between them.
Okay.
Unfortunately, frequently it's actually used as a functional test. If it fails, it is functional, or it's not functional, but it's not really a functional test.
Because I think a lot of people...
It's a diagnostic tool.
Yeah, a lot of people have that difference between was a functional test, even though our team as well as like functional tests, but especially on a semiconductor, actually you have to build the board for the full functional task to process. I know it's a very extensive process and very expensive and time consuming compared to the curve trace, which is a lower cost, but it's just a... how does it work? Is it pin to pin, or how does it do the curve trace? Pin to pin.
Okay. You have to look at the pin out. The pin assignments are on the manufacturer's data sheet. And you say, right, pin 1 is supposed to be connected to pin 8. Are they connected? And the curve is one way if it's shorted out, meaning the wires are crossed. Mm-hmm. If there is no circuit at all, if the circuit's been broken, it's an open. Okay, so it's a different shaped curve. Okay. So we're looking if the pins that are supposed to be connected to each other are connected to each other. You're right, there's no setup time, and we don't need a special fixture for it, but it's slow, because you can only test 2 points at a time, and the devices now are very small. So using manual probes on a target that small, and trying to hold that connection, very, very, very difficult to do manually.
Yes.
So there's much more effective ways of testing.
How would you do that for that when it gets to that small size?
We actually have a custom designed fixture.
Okay.
It will hold the device under test in a specific area, and then the probes are actually managed by mechanical arms. Okay. So we can actually move the probes and hold them in place rather than trying to do that manually. Mm-hmm. But still, the size of the end of the probe sometimes is actually bigger than the target on the very small devices. So some people request it, but we always have to recommend to people what is a higher level of testing, what's recommended.